Hey everyone, welcome back to the channel. First things first, what are the symptoms you might be experiencing? Besides the obvious check engine light, you might notice your car is hard to start, or it might crank for a long time before finally turning over. You could also experience rough idling, engine stalling, a noticeable loss of power, or even poor fuel economy. In some cases, your car might not start at all. These symptoms happen because the camshaft position sensor is a critical part of your engine's timing system. So, what exactly does this sensor do? Think of it as the eyes and ears for your engine's computer, the ECU. It tells the ECU the exact rotational position of the camshaft. The camshaft, in turn, controls the opening and closing of your engine's valves. By knowing the camshaft's position, the ECU can precisely time fuel injection and spark ignition for optimal performance. When the ECU loses this signal, or gets an erratic one, it gets confused. And that's when you get the P0340 code and all those nasty performance issues. Now, let's get to the fun part. Diagnosing and fixing the problem. The P0340 code says circuit malfunction, which is a key clue. It doesn't always mean the sensor itself is bad. It could be the wiring, the connector, or T-sensor. So, don't just rush out and buy a new sensor. Let's be smart about this. First, you'll need a few basic tools. A good OBD scanner, a digital and some basic hand tools like sockets and wrenches to access the sensor. Pop your hood and locate the camshaft position sensor. Its location varies by vehicle, so a quick search for your specific make and model, like 2015 Honda Civic camshaft sensor location, will show you exactly where to look. It's usually on the cylinder head, near the top of the engine. Once you find it, your first step is a thorough visual inspection. This solves more problems than you'd think. Look closely at the electrical connector plugged into the sensor. Is it securely fastened? Are there any signs of corrosion, like green or white crusty stuff on the pins? Are the wires leading to the connector frayed, melted, or damaged in any way? Sometimes, a wire can get too close to a hot engine part and melt, or it can get chewed on by a rodent. If you see any obvious damage, that's likely your culprit. A loose connection can often be fixed just by unplugging the connector, cleaning the contacts with some electrical contact cleaner, and plugging it back in securely until it clicks. If the wiring and connector look perfectly fine, the next step is to test the sensor's circuit. This is where your multimeter comes in handy. Unplug the sensor's connector. You'll typically see 3 wires. One is a power wire, usually 5 volts from the ECU. One is a ground wire, and the third is the signal wire that sends the information back to the ECU. Set your multimeter to DC volts. With the key in the on position but the engine off, touch the black probe of your multimeter to a good ground point on the engine block or the negative battery terminal. Then, carefully probe the terminals inside the connector. One of them should read around 5 volts. That's your power supply. If you don't get 5 volts, you have a wiring issue between the ECU and the sensor, which might require a wiring diagram to trace. Next, check for a good ground. Switch your multimeter to the continuity or resistance setting. Touch one probe to the ground, pin in the connector, and the other to the negative battery terminal. You should get a reading close to 0 ohms, indicating a solid ground connection. If the resistance is high, you have a bad ground wire. If both power and ground check out, the problem is most likely the sensor itself. At this point, replacing the sensor is a pretty safe bet. They are usually held in by just 1 or 2 bolts. Simply unbolt the old sensor, pop the new one in, tighten the bolts to the correct specification, and plug in the connector. Make sure you get a quality OEM or reputable aftermarket sensor. Cheap, no-name sensors can fail quickly or not work correctly right out of the box, leaving you back at square one after you've either repaired the wiring or replaced the sensor. The final step is to clear the trouble code using your OBD to scanner. Then, start the car and take it for a test drive. The check engine light should stay off, and you should notice a significant improvement in how your engine starts and runs. And that's it. You've successfully diagnosed and fixed the P0340 code. You've saved yourself time, money, and learned a valuable skill. If this video helped you out, please give it a thumbs up and consider subscribing for more DIY car repair guides. Drop a comment below if you have any questions or if you've tackled this job yourself. Thanks for watching, and I'll see you in the next one.